One of the things that I love to do most is just sit out in the garden and watch birds feed on the bird feeder. I get a whole lot of different species come in, and they all have their own little peculiarities and personalities. Now, for all those times when I can't be out in the garden, maybe because it's bad weather or I'm just on holiday or something, I put a camera in place so that I could keep an eye on everything. And following on from one of my recent videos about capturing the output from IP web cameras, someone asked the question of whether I could use a camera such as this, along with some artificial intelligence software, to automatically detect what type of bird is at the feeder. Now, this is a really brilliant idea, and it's going to take me a while to do it, but let's give it a go. Hello once again, Pi Geeks and Techno Nerds all over the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. I've been using Raspberry Pi since they first came out, and I wanted to share with you some of the projects that I've done over the years. If you like what you see on this channel, please hit the thumbs up button, subscribe to see more, and hit that notification bell so you can be told when I put a new video out. And let me know in the comments how you get on with this project, and if you've got any ideas for other projects that you'd like to see me do in the future, put those in there as well. Now, before I go any further with this project, I do want to point out two things. First off, I've just got to really apologise to whoever it was who put in the comments suggesting this video. For some strange reason, I can't find the comment anywhere, and so I've lost track of who it was. But thank you so much. I really, really appreciate it. It is a fantastic idea. The other thing I want to fess up to is that there's no way I'm going to be able to complete this project in one video, so this will end up being a series. Of course, as always, I'll be breaking the video up into chapters, and so you can jump to the relevant bits, so I hope it's not too much of a problem if this project spans a few videos, because at least you can jump around to the bits that are of interest to you. But now, let's get on with it. Now, just like the Amazon Ring system, you can connect video feeds and artificial intelligence together in order to do object detection within the video. Items can be identified in the video, along with their location, so you can see what is in it. Now, the Amazon Ring system is specifically designed to do things like pick up if there are intruders around your house or if a parcel has been left at the front door. But fundamentally, if you train up an AI model, you can use it to detect anything within a video feed. And so my intent here is to use AI to detect different species of birds on my feeder and have it present those in real time. Now, the very first stage of this is just to simply capture some images from my webcam and run them through an AI model just to see how well it does. There are a whole bunch of models out there that claim to be able to classify different types of birds. So I'm going to try one out here and just see how it gets on. In future videos, we'll take the project further, right up to the point where we end up with our real-time feed of identified birds. Now let's take a look at what you need for this project. Now, the kit list that you need for this project is really quite small. The first thing you're going to need is a Raspberry Pi 5. It really needs to be the Pi 5 because you need as much processing power as you can get. Now, obviously, the other thing that you'll need is an IP web camera. Assuming you're doing the same as me, you'll need one that is weatherproof, so that things like rain and snow won't affect it at all. Now, this is the one that I picked up, but don't feel that you need to pick up this exact model. The really important thing here is that it says it's IP67 waterproof. This standard is applied to anything that can easily survive things like rainfall. Now, as you can see, this one was relatively expensive, and it's really because it's a 4K camera. You don't have to have 4K at all. A regular HD camera would be absolutely fine, and you can pick those up for a lot less money. The next thing that you'll need for this project is a tool called FFMPEG, and you can install that easily with this command here. Now that's installed successfully, and you can make sure that it will run okay just by typing FFmpeg. And then you'll get the basic help text showing the configuration that it was built with. The only other thing that you'll need on your Raspberry Pi for this to work is Docker and Docker Compose. And you can install these really easily just with the command sudo apt install -y docker docker.io docker compose. Now the purpose of this initial video is just to capture some images from my webcam and then run those through an AI model to see how good the bird classification is. Now in order to run these tests, I've got this repository here in my GitHub repo. And as it says in the description here, this is a fork of code that was originally written by the secret Batcave. The code that guy wrote about 7 years ago to do something very, very similar to this was actually really good. And all I've had to do is bring the Python code a little bit more up to date so that it can run using Python version 3. So I just want to credit Secret Batcave with all of the original code. What he wrote is really great and very easy to use. Now, in order to grab this code, all you have to do is drop down the code button here, copy the link, and then in a terminal window, type git clone, and then paste in the link. Everything's then pulled down and you're ready to roll. Now, before we can do anything with the code, I actually need to capture some images from my webcam. To do this, I'm going to use a tool called FFMPEG. This is sometimes referred to as the Swiss Army knife of video processing. It is truly remarkable software. And you can use it to do all kinds of things. But in this case, I'll be giving it my video stream and then telling it to extract an image every 30 seconds from it. So let's go and take a look at that. Now, even though the webcam that I have is capable of doing 4K, I actually have it set up at 1440p. And the reason for this is because if I use any resolution higher than that, the camera actually generates a video stream using a codec called HEVC. And that makes it a lot more difficult to develop web pages to consume that. Whereas using 1440p or a lower resolution results in the camera using a codec called H.264. And that is much better supported for displaying web pages. So where I have my own web page set up to keep an eye on the camera, I use that. However, if all you're using is the native application to access your webcam, you could set it at 4K and that would work just fine. FFmpeg won't have a problem with that. So if I switch to my Pi terminal, I've now moved into the directory that I cloned all of our code into. And now I'm going to create a directory in here called My Images. And this is the command that I'm going to use to capture images every 30 seconds. The first parameter to this just says that I'm not interested in any frames that aren't what are called keyframes or full frames of video. The next parameter defines the URI that I need to use in order to access my video stream. Now, just like in an earlier video when I talked about capturing video streams from webcams, you can look up on the iSpy Connect website what the access URL is for the video stream on your IP camera. And I'll put the link to the iSpy Connect website down in the description below. The next parameter uses what's called in FFmpeg a filter. And in this case, I'm using a filter called FPS. Now this may look like I'm trying to define a frames per second value of 1/30th of a second, but I'm really not. What this is saying is that I want to capture one frame every 30 seconds. So it's not particularly intuitive, but it is very effective. The last part of the command defines where the images are going to be written on my hard disk and what file name is going to be used. This crazy nomenclature here means that FFmpeg will create a file name for each image that's written. The file name will consist of a number that's 7 digits long and will be 0 padded, starting at 1 and ticking up. And then all of these will have a .jpg extension. And now we can just run it. As FFmpeg runs, it will give you a lot of very confusing output here. It probably won't make a lot of sense to you, and that's okay. Just leave it running and it will be absolutely fine. If you open a new tab in your terminal, you can then use this command here to keep an eye on how many images have been written. Here you can see I've got 3 so far. I'm just going to leave this running for a while and then we can come back and see the results. Okay, It's been a little while now, and I'm just going to cancel the FFMPEG capture with Control-C. I've deleted the images where there was no bird on the bird feeder at all. Now if I just click through what's remaining, you can see that all of these have got birds in various angles, all on the bird feeder. Now all of these are just little house sparrows. So I don't have a lot of variety here in these images, but it's still a set of images that we can use to test the AI. Now before we run this code, I wanted to show you a bit about what it's doing. If we go all the way to the bottom, we see the main function, and the first thing it does is it runs this function called create_graph. That runs this code here. Now this is using an artificial intelligence library called TensorFlow. This is a very popular AI library and is really good for things like object detection. So in this case, TensorFlow is just opening up a pre-trained AI model that's been trained against a set of common UK birds. If I go into the models directory and then I open this file called ukgardenmodel_labels.txt, these are all of the different types of animal that have been trained in the model. Now most of these are birds, but there are some other animals in there as well, such as squirrels and cats that you may typically find around a bird feeder. Now for me, since this model has been trained to recognise a house sparrow, and that's what we were seeing in the images that I've captured most of the time, I would expect it to be able to pick this out quite successfully. Moving back to the code, after it's created the AI model, it then calls this function called findImages. Now findImages just does a directory listing of a directory called test_images that it expects to find. It will search specifically for anything with a .jpg extension. So it's really important that we saved our images in that format. It then runs this function, run inference on image, against every image that it finds within that directory. And that's this function here. It firstly pulls in the image data by reading the image file. It then asks TensorFlow to run its analysis of the image and bring back the objects that it thinks are in the image. It then uses another library called NumPy, that's a kind of mathematical analysis library, to bring out the top 5 results. It then opens up the labels file, which is the list of all of the different entities that it can recognise that I showed you in that text file. Now originally the code would actually show you the top 5 results, but just for the sake of this exercise, I've commented that out. And instead, I'm only making it display what the most likely object is that it's found. Alongside this, I also print out the percentage confidence that the system has that this identification is correct. So as you can see, the code is actually really quite simple for this. The Python programming language and the TensorFlow AI library make it remarkably easy to do this kind of project. Now, as is very typical with me, I like to run pretty much everything inside a Docker container. And the reason for this is that I can build a really predictable runtime environment. And so I do this here. I base my Docker container on an Ubuntu 24.04 image. I bring that up to date with any new software that's been released for it, and I then install all of the Python tools that I need. I then set up a virtual environment for my runtime, and I install both TensorFlow and NumPy into that. I add in our bird Python script, our data models, and our test images. I then say that when the Docker container runs up, by default, I want it to run my bird.py script. Now there are a number of images that Secret Batcave provided with the source code in order to test things out. And you can see these here. Now these are really pretty good quality close-up views of each of these birds, so I'd expect them to be identified really pretty easily. So let's go and build the Docker container and then see how well it runs. To build the container, I just have to use the command docker build -t, and then I provide a tag for this container. So I'm just going to call this Jeff's Pie in the Sky /bird classifier : 0.0.1. I then have to point it to my Docker file. So I say -f Docker file, and then the directory that I need to run in, which is the current directory. So I just put dot. Okay, So now everything's built, we can try running it against the test images that the bird classifier code came with. I can do this just by running the container with docker run -it --rm so that it will clean up after itself when it exits, and then the name of the container, Jeff's Pie in the Sky /bird classifier :0.0.1. Here, you can see that most of the times the confidence score is actually pretty high. And for sure, given that robin2.jpg had a confidence score of 91.55%, if we look at the image that came from, that makes sense. It's a very good picture of a robin. And that comes down to the worst case, which is the picture of the parakeet, where the software has identified that as a robin, but only with 47% confidence. And again, that makes some sense when you take into account that the actual image is first off much smaller, and secondly that the bird isn't particularly clear. However, given it's a completely different colour, then that does seem like a very strange result. Just shows that AI is certainly not perfect. But now let's try running it against our own images. In order to do this, I'm going to run the container again, but this time specifying this extra parameter. And what this is going to do is it's going to take the directory where all of my images were stored that I captured from my web camera, and it's going to mount those into the container in the location /test images. This means it's effectively going to overwrite at runtime the directory that is storing all of the test images. So the software won't know any different, it's just going to see a different set of images. Now let's run this and see what happens. Now the results here have been a lot less convincing. For example, this last one here is thinking that the most likely detected object is a cat with 34% confidence. But if we actually take a look at that particular image, there's no bird in it at all, and there's certainly not a cat. So that's really strange. The case where it was most confident was this one with image 6, where it was saying that this was a robin with 63.8% confidence. But again, if we look at the actual image, then we can see it's not actually a robin at all. It was a house sparrow. Now granted, the two birds are quite similar in shape and size, but a robin has a very distinctive red breast on it. So again, the software hasn't done a great job here in detecting the type of bird. So why is this? Why are we getting much worse results when looking at my own images compared to the images that were provided along with the software? Well, I think a lot of it comes down to the fact that in the images that were supplied, they were clear, close-up pictures in most cases of the actual birds. And in the cases where they weren't, then the software really struggled. Now, if you take a look at my images, the bird only actually forms a very small portion of the image. And everything else, like the bird bath, the bush, the leaves, the feeding tubes, all of this is stuff that the artificial intelligence has no idea about. And this is where artificial intelligence can sometimes turn into very real dumbness. It doesn't have the ability to be inquisitive. It only knows about what you train it on. And as such, it doesn't know what to ignore in the image. So you could, just as an example, have a shadow in the image somewhere and that get misidentified as a crow just because it's a large black object. Because it doesn't know what to ignore, it doesn't know what to identify. And so when you take that into consideration, it's actually working in a really remarkably smart way. I think if I was able to train this model using my own images as the training data, I think it would work much better. Because off the back of that, it would know what to ignore. I would be telling it, this is a bird in my particular picture. And so it would know better what it's targeting. Because I would never identify a leaf or a feeding tube or a bird bath or a shadow as a bird, it would know to ignore these things. And so in the next part of this series, that's what I'm going to try to do. I'll put some software together that I'll then be able to use to identify where birds are in my images and provide the information to the data model to say what type of bird it is. I'll then apply several hundred of these images in as training data, And after that, I can repeat this exercise again, capturing fresh images from my webcam to see how well it then performs at identifying the individual birds. But that is going to take a lot of learning on my part, and so I can't include that in this video here. So please stay tuned for the next part of this series. If you like this video, please hit that thumbs up button and subscribe if you do want to see the next part of this video, and hit the notification bell so you can be told when it comes out. Also, let me know in the comments if you've got any experience with artificial intelligence and you can provide some advice on where I'm going wrong with this and anything I can do better. I'd really appreciate all the help I can get here. I know very little about AI, and so I'm very much learning as I go along. But thanks so much for watching till the end of this part of the series. And until next time, bye for now.